Welcome, and in this knowledge clip I will show you how to do a cross-variable analysis for the sample and for the population in the case where we cross a nominal or ordinal variable as the independent variable with a scale variable as the dependent variable. Now again, I'm going to use for that a case study about an indoor swimming pool with some questions. Where are my questions? Here. Here are my questions. So you see some of the questions are what is your gender, for example, and you can be male or you can be female. And one of the other questions is which score between 1 and 10 would you give the indoor swimming pool splash film? And also other questions as well, of course. Now here in the Excel file I have a data sheet containing all the answers to the questions of those people. So right now I'm going to analyze a research question crossing two variables of that survey. And you see here my research question: is there a difference in satisfaction score between the males and the females? So I'm going to cross here the satisfaction score, let's highlight that, and I'm going to cross that with the gender question. Now, if you do a cross analysis using a research question, we will always first want to know what is the dependent variable and what is the independent variable, because that will determine how we will analyze this research question for the sample and for the population. Now, the satisfaction score is our dependent variable in this case, because that's the variable that we want to explain. We want to see if there is a difference there regarding the males and the females. And that dependent variable, if we go back to our questionnaire, we will see that that question itself is a scale variable, because you see that we have an open-ended question here in number 6, ... We need to fill in a value, so this is called a scale variable. So this dependent variable has the scale measure. The gender is our independent variable, and the independent variable in this case is a nominal question, because we just have the male and the female category, meaning just two categories that you cannot sort. That's a nominal variable. So if we wanted to do our sample analysis right now, we will see, if we go back to our decision scheme here, that we are in the second box of my decision scheme, where we cross nominals or ordinals as independent variable with a scale variable as a dependent variable. In that scenario, we can no longer do cross-table analysis or cross-bar charts. No, we're just going to compare the means and then do an ANOVA tests. So let's go back to my Excel file and let's try to do that. So we're going to compare the means. So in other words, I just want to check if the average satisfaction score of the males and the females is different. Therefore, we're going to insert a pivot table, and this pivot table will contain all the data of my data sheet. And let's then calculate the averages of both genders. So in other words, I'm going to put the gender in my rows, and then I have a number 1 and number 2. I have to check number 1 is male and number 2 is female. So we have male and female here. And of both these genders, we just want to calculate the average satisfaction score. So I'm going to put the score in my values, and instead of calculating the sum, I will change my value field settings into an average, into the mean, in other words. So right now I can compare both means, and I see that the males have an average satisfaction score of 6.4 and the females have an average satisfaction score of 6.7. Apparently the females are a little bit more happy compared to the males. And that is my sample analysis. I conclude that the females are a little bit more happy than the males. But then again, this is just a sample analysis, of course. This is only true for the people in my sample. Can I extend that conclusion to the population? Well, therefore, we have to do the population analysis, and therefore we need a statistical test. So let's first try to identify which test that we need for that. Going to my decision scheme, we see that that is the ANOVA test, which stands for the analysis of variance. That's the test that we're going to use to see if my sample conclusion is also valid for all my customers, for my population. And therefore we start with the null hypothesis, the starting hypothesis of every statistical test. And every statistical test assumes equality, that there is no difference between, in this case, the average satisfaction score of the males and females. So that is our starting hypothesis, the null hypothesis. And then we're going to test that. And we test that by calculating a measure of difference. And that measure of difference will summarize in one value all the differences that we observe here in my table where I compare the averages. And that measure of difference is the ANOVA F value in this case. And to calculate this and to see if the difference that we observe here in our table is significant, in other words, if we can extend the conclusion to the population, we will do that ANOVA test. Going back to my decision scheme here, scrolling down, I will find a link that will guide me to that ANOVA test calculator, where you see that you will have to fill in the treatment scores of the different groups that you're comparing. Or in other words, we need to have a list of the scores of all the males and then a score of all the females. How can we do that quickly? Well, I'm just going to copy paste the gender and the score here to my sheet where I'm working here where I'm doing my cross analysis, and I'm just going to sort my gender from low to high, small to large, and that means you can see that changes of course the scores as well, or in other words the ones are all the males, so next to the ones I have the scores of all the males, and then next to the twos I have the scores of all the females. So let's maybe construct a table right now with the score of the males and the scores of the females. So in other words, I will copy the satisfaction scores of all the genders, the gender ones, which indicate the males. So let's copy paste them. Oh, one more. That's here. So that's the score of all the males. And then we will also do that for the scores of all the females. So let's copy paste right now all the scores next to the twos under the scores of the females. So now I have a list of the scores of all the males with number 1 indicated by number 1 and the scores of all the females indicated by number 2. You can also clearly see, if I scroll down a little bit, that that list of the females is bigger than that list of the males. So meaning that we do have more females. So we can never just compare the sum of the scores, of course, because yeah, we're just with more females, and the sum of the scores of the females will just be higher because we have more females. That's why we compare the averages. So now we have two lists here, and the only thing that I'm now going to do is to copy paste those two lists into my treatments here in my treatment lists of that online calculator. So treatment 1 is a satisfaction score of all the males, and then treatment 2 is a satisfaction score of all the females. So let's copy paste that over here. Then again, I will do this with a significance level of 5%. Let's calculate this, and then is here my result. Let's again copy paste this to my Excel sheets, because that is what I need to draw right now a conclusion for the population. See the differences that I observe in the sample can be extended to the population. Good, and it takes a while to snip it, but there it is. Good, so here is my outputs of that ANOVA tests. And we will see that the F value, the value of difference, or the summarizing value that summarizes the difference that we observe in the sample, is 1.19355. That is the F value, that is the ANOVA value of difference. Now we will see, is that a lot or not? Is that measure of difference, is that difference significant or not? Is that a significant difference or not? and therefore we use that p-value, and the p-value is a percentage. Actually it's 0.27639, and we will transform that into a percentage and then compare to our significance level of 5%. So in the fifth step we'll see if our p-value is bigger or smaller than that 5%. In this case our p-value, which is 27.639%, is clearly bigger than 5%, meaning that the difference that we observe in our sample is not significant. The difference is not statistically significant. Or in other words, we will not reject our null hypothesis. And that means that the difference that we observe in the sample is actually too small, not significant, insignificant, to extend our sample conclusion to our population. So in our sample we have seen that the females tend to be a little bit more happy compared to the males on average, but that difference is insignificant for your entire population. You cannot extend that conclusion to your population. It was a coincidence. Maybe on that particular day when you went to that swimming pool there was indeed a difference between the males and the females, but if you would go back and do your survey over and over and over and over again, you will not find that same difference in at least 95% of the cases. So we say that it is not significant at a 95% confidence level. And that is how you analyze such a research question for the sample and for the population.